I have to start off with, it has been awesome being here, and it's really like coming home. So I think we should side brand NAV into Network Automation Family, because I'm sure a lot of people feel the same way. BMP, BGP Monitoring Protocol. And let's start off with, a lot of you have been here, right? You've been going through devices, endless devices on scraping and getting every bit and byte out of that box and going looping through them, interfaces, neighbors, processing all of that data. You get some awesome and magnificent and unbeatable regex to get that all done. Imagine doing that continuously on a service provider network. You got 60 plus pops, right? 2 routers per pop and stuff. And continuously doing that while trying to keep up to date for BGP on every peer that you have. Let's focus on customer peers, right? But going through that and getting every prefix from that peer, getting all the details of it, and having that for the pre and post BGP information. There is no magic command that you get a full JSON on all of that information, so you would literally need to do that on a peer-by-peer basis, pre and post command, right? It's going to kill the box. I'm Bart Dorlandt. I'm a freelancer. I'm living in the Netherlands. I have my company, Dream Networking and Automation. I dream about it, literally. It's also in my DNA for everybody. It's very quick, and it's what I love doing. I'm taking you on a journey on how BMP is implemented at my client. The use case is about having a feedback loop towards the customer. So there's a given that the network part of it is already configured or automatically configured whenever they make changes. So they would go through a portal, put in their prefixes that they want to have prevented or protected for the anti-DDoS solution, and they throw that in there. The automation takes care of all the configuration. What didn't happen was providing a feedback loop and giving the customer in the GUI the view of like, hey, green box, and everything's working, everything's good, right? Not even a red box, nothing. So there was always a challenge. What if we can fix that and we can have, in this case, BMP use that and having the routers push the information, go through the network, eventually ending up on the portal and showing that and having all of the details that go with each of those prefixes, giving the green checkbox and all of the details with them if they want to look at those, like, hey, are all my communities accepted and all fine and good? And for our use case, we want to see the pre and the post policy information. So, architecture. You have the box at the bottom, right? The POP that's replicated 60 plus times, right? The router will push its information, not pull, will push the information into the collector. There it does some processing. It makes a protobuf out of it. It goes into Kafka. Consumer picks it up eventually, puts it in a database, right? In front of that, there's an API, and there we got the other team, which is responsible of the GUI and the portal and the customer side of things. So they would just scrape the API continuously and getting all the updates. Throw that in their DB because they need less information than what we actually get, and present that in the portal, right? Easy peasy lemon squeezy. So details, we're technical here, so we want to know what's going on. So the collector is written in Go. That's based on the BBMP to Kafka library, which is more of a shell around the BioRD library. Messages, as mentioned, are going in protobufs over Kafka. The consumer is homegrown, so that picks it up and translates that into the database, which is a Postgres-alike or RDB on AWS. And then we got an API that is an AWS gateway with a Lambda in Python. Not everything went smooth, right? We hear the success stories, but we got the pain as well. And we need to highlight those as well to learn from each other. So taking the collector, right, the BBMP to Kafka out of the box, You put it in and put it on and let the magic happen, right? Then you realize, okay, well, we got a couple of ISPs. These days, 1 million per IPv4 peer on the internet of prefixes. You got all the customers, all the stuff. We're seeing a throughput of 30 messages per second. That takes a very, very long time to get that processed and get it eventually in the database. So first fix on that code was, okay, can we just create a pool of asynchronous producers, do a bit of fixes on that to allow more open requests on that by default and less strict acknowledgement. Some Kafka details, if you want to talk about it, see me. And then we can actually bump it up to 45K messages per second. So that was a huge increasement. For Brian, right, wanting everything often leads to having nothing. We did not put initially filters on that, so we got everything. Like we got per router, 4 ISPs, then you got the internal mesh, you got internal stuff on the POP, you got customers, which are the important picture of it. That led to millions and millions. If you calculate that throughout the world, then you got billions of entries that needed to go into the database. So quite quickly, we killed the database, and we needed to solve that. So filters to this, make sure that you only get what you want. Sounds simple, it's quite important. Information can still be used, but don't push it all into Kafka, right? For us, the customer data was the most important part of it. So not every open source thing out there is an exact match to what you need. And we realized that we needed to fix some things or add some things. So out of the box, Kafka, it had Kafka support, but we wanted TLS on there, so that's done. We realized that we got all of the BGP update and withdraw things from the router. What we didn't get was peer down notification. So the database was saying, yeah, sure, these prefixes, they're all alive and everything is announced and all is good. While the router was saying, well, actually the whole peer is down, so you don't have those prefixes. So we realized, hey, well, actually missing were peer down notifications. It's kind of important to flush everything into the database as well. So we got these filters in place. That gives us the ability to still say, okay, well, this is internet traffic, this is customer traffic, and we're going to highlight that as well. So not everything has to go into Kafka and into the database, but having it in Prometheus is actually very useful. So that's also useful for the network engineering team and the NOC, and everybody can see, okay, well, actually that peer went down 3 days ago, and we saw the flap, and so that's some side bonuses. During the way, there was a warning that we got where the valid BGP identifiers look at the PR. That got fixed, so you don't have that problem anymore. Key results. Closed loop, back to the customer, right? We got no human intervention in between anymore. Sure, there's a bit of delay, right? They configure it, they need to do stuff. We need to do stuff, and eventually that goes all back. It's a push model, so whatever the router gets streamed, gets pushed upstream, right? So you don't miss anything. It's actually very useful to have a push model instead of a pull model on that. The hierarchy fits, right? This hierarchy sounds easy, right? But it goes over multiple teams, so that's a challenge or not within your company if you want to implement that. But for us, that hierarchy fitted. We already had Kafka, so that was an easy thing to do. Information, right? The Prometheus metrics a bunch come out of the box, but having that on the filtering as well and only going the customer data upstream was good. Having the other data in Prometheus was very useful and proved to be very useful. Knock on something, right? It proved to be very low maintenance. We did not have literally any issues with it, so that was a great success. And I would say the biggest takeaway out of it is focus on what you need, right? Focus on importance, because we enabled it and it got everything, and it had 18 million entries from a single router, and it's like, yeah, it's kind of killing things along the way. So focus on what you need, and that's the most important part. Thank you.